Assalamualaikum warahmatullahi wabarakatuh. Welcome to the welding part 6, which is the final part of welding topic. Assalamualaikum everyone. So let us continue with the solid state welding, which are the diffusion welding, friction welding, and also ultrasonic vibration welding. What is solid state welding? So in solid state welding, coalescence of the part surface is achieved via three methods. One is pressure alone, and second is heat and pressure, where both heat and pressure are used. Heat is not enough to melt work surface compared to the one that used in the fusion welding. And for some solid state welding, there are also time also become a factor in the welding process. So in this process, no filler metal will be added, and each of the solid state welding process has its own way of creating a bond on the fairing surfaces. The success factor in the solid state welding are very dependent on the fairing surface. So during the solid state welding, the fairing surface must be very clean, and it must be very close in physical contact. So meaning that the fairing surface must be in close contact. If it is not close contact and not a very clean surface, then most probably the welding will be a failure. So, for solid state welding, the advantage over the fusion welding is, of course, there is no melting in this process. Therefore, no heat affected zone, so metal around the joint will retain original properties. And then many of the solid state welding process produce welded joint that bond the entire contact interface. So, for example, if you use the arc welding or the oxyfuel gas welding, only certain area is welded, right? Or maybe you can just make a point of welding, but in this process, the whole contact area will be joined together. And then for solid state welding process also, it can be used to bond dissimilar metal, meaning for example ceramic and metal, or maybe ceramic metal with different type, for example the aluminium and stainless steel or something like that. So without any concern of a relative melting point or thermal expansion or other problem that arise in the fusion welding. So here are some of the processes in the solid state welding. We have forge welding, cold welding, roll welding, hot pressure welding, explosion welding, diffusion welding, friction welding, and ultrasonic welding. There are a lot more actually, but don't worry, we are not going to cover everything. So there are a lot. As mentioned previously, there are more than 50 type of welding in this world, right? So in this process, we are going to cover the most popular one, which are ultrasonic welding, friction welding, and diffusion welding. Let's see the diffusion welding first. So the diffusion welding is a process where heat and pressure is used to control the atmosphere, and then with sufficient time, the diffusion between the material will happen, and then coalescence will occur. So in this process, the temperature is below 0.5 the melting temperature of the metal that we want to join together. So in this process, plastic deformation will be very minimum, and then the primary coalescence mechanism is solid state diffusion. So meaning that the atom in between the two material will start to diffuse into each other, and the limitation will be the time required for the diffusion can range from seconds to hours. So this one is depending on the process and also the temperature that we use. Okay, so let's see the arrangement of the diffusion welding. So simply how we can see the setup for the diffusion welding is like this one. So they are going to have the substrate, okay, the one that you want to diffuse, and then the part that you want to produce, okay, and then you apply the force and also heat together, then the part will diffuse to the substrate here. Okay, so this is how the process take place. So for example, this is two material at the fairing surface. So when you apply the pressure and also the heat, the atom in between these two type of material will start to diffuse into each other, and then will create the joining process. Diffusion welding usually applied in the high strength and refractory material. So for example, in the aerospace and also in nuclear industry, where you want a very a strong welding process, and we don't want any leakage in the process of the welding. Okay, so it can be used to join either similar or dissimilar metal. So for joining dissimilar metal, you might need a filler layer of different metal, so that it can sandwich between the base metal to promote diffusion. So friction welding, as its name, so the process is achieved by a coalescence through the frictional heat, okay, combined with the pressure. So when this friction welding is carried out properly, there will be no melting occur at fairing surfaces. So in this process, no filler metal, flux, or shielding gas will be used, and can be used to join dissimilar metal. For example, ceramic and also the metal, you can easily combine it together. So this one is widely used for commercial process, amenable to automation and mass production. So let's see the process of the friction welding. So for example, this is the two cylindrical part that clamp to the rotating chuck. Okay, one of the part will not be rotate. So this one is non-rotational chuck. Okay, this metal is not going to move, and this one will be rotating. Okay, so it will rotate at a very high velocity. Okay, and then when this one part brought into contact, there will be a contact between the two material to create the friction heat. Okay, and then rotational stop and axial pressure applied. So once there is a friction over here, so what happen is you just apply the force so that the part will create the joint, and then there is no rotation anymore, okay, on this one, and then in the end the weld will be created on the product. Now let us see the process. This is how the process take place. If you can see, this is the area where the friction happen, and then the part will start to join, and then the rotation stop, and then the part will leave to join into each other. So for the friction welding, the application are usually used for the shaft and tubular part, so that because it's easier to for you to perform the rotation, right? So the application usually used in the industries like automotive, aircraft, farm equipment, petroleum, and natural gas. So the limitation will be at least one of the part must be rotational. So if it is not rotational, then you will not be able to create the friction heats, right? The second one, there will be flash. So if you can see previously, there are flash coming out. Okay, so must usually be removed. So you have to remove the flash also. So then, meaning that there will be extra operation. And then upsetting reduce the part length. So if you can see, because of that flash, so the normal dimension will be shorter. Okay, the dimension will be shorter of the part joint. So you must take into account on this thing when you want to design the process. Okay, so this is the cross section of the friction part. Okay, friction welding part. So this is the flash. If you can see, these are the flash. So this one, these are the flash, and this is the area that joint happen. If you can see, there barely any difference in terms of the microstructure of the parts. Okay, so meaning that the properties here, there's no harsh area over here, and the only things that left that you have to remove will be the flash. Another type of friction welding is we call as friction stir welding. So in this process, the rotating tool is fed along a joint line between two workpieces and then generate friction heat and mechanically stirring the metal to form the weld seam. So this one is a little bit different from the friction welding because heat is generated by the separate wear resistant tool rather than the part. So previously in the friction welding, the friction is produced by the two part, right? So but this one for friction stir welding, you need a tool for it. So the application will be the butt joint in large aluminum part in aerospace, automotive, and shipbuilding. Is the schematic diagram for the friction stir welding. You will have this one is the part, okay, so this is a butt joint area. So and this one, it will be the rotating tool to create the friction stir in the metal. So there will be a tool with the probe on this one, okay. So this probe will this tool will be rotating, okay. So then it will uh, stir the part over here, okay, and then create the welding on the part like this one. So here is the simulation for the friction stir welding. So if you can see this, the tool is going inside and then they will create the friction on this area because this tool is rotating, and then it will create the weld butt on the area over here. Now let us see the actual process. So if you can see there, the probe going inside the two parts, okay, and then they are going to stir inside here, okay, and then create the friction in between the parts and then create the butt joint. So compared to the normal butt joint, as this one, the part will be cleaner, okay. So and then you can create a straight, meaning the flat welding, okay. So if you can see on the surface here, inside there, okay, so they are leaving this area flat, okay, compared to the one that we perform in the arc welding or in the so let's see the advantages and disadvantages of friction stir welding. So it gives a good mechanical properties of weld joint, avoid toxin fume, warping and shielding issues, little distortion or shrinkage, and good weld appearance. Like I mentioned previously, it's going to create a flat area for the welding. And then for the disadvantage is there'll be a possibility of exit hole is produced when the tool is withdrawn. So meaning that after the tool is coming out from the part that join, they might leave hole because of that probe, okay. So heavy duty clamping of part is required. So as you see in the video previously, because they are going to stir the material, right? So if you didn't clamp it properly, the part might be moving, right? So then the process will be a failure. So the last process will be ultrasonic welding. So in ultrasonic welding, two components are held together, and the welding process is performed via the oscillatory shear stress of the ultrasonic frequency, where this ultrasonic frequency is applied to the interface area to cause the coalescence. So this oscillatory motion break down any surface film and then allow intimate contact and strong metallurgical bonding between the surfaces. Usually the temperature used is below the melting temperature and no filler metal, flux or shielding gases needed. Generally, it limit to lap joint on soft material. For example, the wiring for in the car, okay. So and other soft material like the copper or aluminium, something like that. Now here is the ultrasonic welding diagram. So if you can see, there'll be this arrangement. So where there is ultrasonic transducer that make the tool that we want to the tip where the welding take place to vibrate using the ultrasonic vibration. Okay, and then the part to be welded will be placed together. When we apply the ultrasonic, then this part will be bonded together. Okay, so in this process, of course, if you can see, there are mesh over here, right? So meaning there will be pressure and also force applied on the surface so that the part can be welded together. So there will be a vibratory motion. Okay, so then it will vibrate multiple time on here, and then we'll create the bonding in between the material over here. Let's see the animation, how the process take place. If you can see here, uh, the part together, and then there will be some vibration over here. Okay, ultrasonic vibration, and then the part will be joined together. Among the application of the ultrasonic welding will be in the wire and splicing in electrical and also electronic industry, so that in this process you can eliminate the soldering. So you can refer to the video that I'm going to attach the link in the final slide later on. So you will see the difference of the process when you don't have to conduct the soldering anymore. Okay, and second, assembly of aluminum sheet metal panel can also be using the ultrasonic vibration welding, and then welding of tube to sheet in solar panel, and also assembly of small part in the automotive industry. So let's see the ultrasonic vibration welding. So here is the two part, the black and also the white one need to be combined together. So if you can see, it is placed up and down like this, and then the ultrasonic vibration is applied, and these two part is joined together. So here are the links to the video. So please look into the videos and you will learn a lot more and understand on how the process will take place. Okay, so that's the end for welding topic. Thank you very much everyone. Assalamualaikum.